Good morning, Amma. This is Paulam Naresh, chemistry lecturer from DVR Academy. Today, I would like to deal with Fajans rules for the determination of covalent character in a ionic bond. Actually, in ionic bond, there is no overlapping concept, Amma. The electrons have been transferred from one element to another element, generally from metal to non-metal. Those metal which loses electrons will acquire positive charge. Those metal which gains electrons will acquire negative charge. So there will be a bond between, for example, if you are having sodium solid plus half Cl2 gas, Amma, that will produce NaCl solid, perhaps it is. So this NaCl will be dissociated into Na plus and Cl minus. There is an electron transfer between the sodium and chlorine. Sodium and chlorine. There is no overlapping concept. Whereas if you are preparing the H2 molecule, there is a SS overlapping will take place. SS overlapping will take place. Hence, that leads to the formation of the covalent bond. So the point here it is the electron transfer takes place between the metal and non-metal that will produce ionic bond. Overlapping of the atomic orbital concept is prerogative for covalent bond. But what is the heading here we have taken? Covalent character in ionic bond. What is the meaning of that one? So therefore, in order to produce this kind of behavior, there should be a little overlap between the cation and the anion. When that overlap will be happens, I am separating this into two separate headings. Amma. This first line, this is for cation and this is for anion. Anion. Cation should have polarizing power. Polarizing power. And anion should be easily polarizable. Easily polarizable. So cation should have polarizing power. Anion should be easily polarizable. If cation is having more polarizing power, then it will produce the more covalent character. If anion is easily polarizable, then it can produce the more covalent nature. Now, which type of cations will having the polarizing power? First one, Amma, size of the cation. Size of the cation. Small size cation. Small size cation will have more polarizing power. Cation size చిన్నగా ఉంటే దానికి polarizing power ఎక్కువగా ఉంటుందమ్మా. Small size cation will have polarizing power. So therefore, if you are having Li plus, Na plus, K plus, Rb plus, and Cs plus, so size Cs plus greater than, Rb plus greater than, K plus greater than, Na plus greater than, Li plus. But polarizing power, Li plus greater than, Na plus greater than, K plus greater than, Rb plus greater than, Cs plus, that is what polarizing power. Whereas in the case of anion, the same concept we will apply here also. Large size anion will be polarized easily. Will be polarized easily. So for example, F minus, Cl minus, Br minus, and I minus. Actually, the size I minus is greater than, Br minus greater than, Cl minus greater than, F minus. That is what polarizability also. Polarizability also. Now, here second point. Charge. Nuclear charge on the anion. Nuclear charge on the cation. I'm sorry, I told anion. Nuclear charge on the cation. What is the meaning of nuclear charge? Positive charges. As the number of positive charges increases, size decreases. Size decreases. So the statement is, as the nuclear charge increases, size decreases. సో సైజ్ డిక్రీజ్ అయితే మోర్ పోలరైజింగ్ పవర్ వస్తుందమ్మా. నౌ దిస్ విల్ బి Li ప్లస్ Be plus 2, P plus 3. And at the same time, Fe plus 2, Fe plus 3. And at the same time, Sn plus 2, Sn plus 4. So Li plus having 2 electrons, Be plus 2, 2 electrons, P plus 3, 2 electrons. They are isoelectronic species. The polarizing power is B plus 3 greater than, Be plus 2 greater than Li plus m. Whereas in the case of iron, Fe plus 2 versus Fe plus 3, Fe plus 3 ferric is having more number of positive charges, hence lesser the size. So therefore, Fe plus 3 polarizing power is greater than Fe plus 2. Sn plus 4 polarizing power is greater than Sn plus 4. Whereas second point, this side you see, number of negative charges on anion. సో ఇక్కడ పాయింట్ ఏంటి? యాజ్ ద నెంబర్ ఆఫ్ నెగిటివ్ చార్జెస్ ఇంక్రీజెస్, సైజ్ ఇంక్రీజెస్ అమ్మా. యానయన్ సైజ్ ఇంక్రీజ్ అయితే ఈజీగా పోలరైజ్ చేయొచ్చు. అది అంత ఈజీగా పోలరైజ్ అయితే కోవలెంట్ నేచర్ అంత ఎక్కువగా ప్రొడ్యూస్ అవుతుంది. సో అగైన్ సేమ్ స్టోరీ ఏంటంటే ఐసో ఎలక్ట్రానిక్ స్పీసీస్ తీసుకుందాం. N-3, O-2, F-, వీళ్ళందరిలో 10 ఎలక్ట్రాన్స్ ఉంటాయి. అప్పుడు సైజ్ ఏంటి? N-3 గ్రేటర్ దాన్, O-2 గ్రేటర్ దాన్, F-. దిస్ ఈజ్ సైజ్ యాజ్ వెల్ యాజ్ పోలరైజబిలిటీ ఆర్డర్. Size as well as polarizability order. Okay, right. Third point, cation with the pseudo inert gas configuration. Cation with the pseudo inert gas configuration. Actually, if our metal cation is having 8 electrons in its valence shell, then it is having inert gas configuration. If it is having 18 electrons in its valence shell, it will produce pseudo inert gas configuration. 1 minute. So 18 electrons in valence shell, 18 electrons in valence shell, inert gas configuration. 18 electrons in valence shell, pseudo inert gas configuration. Pseudo inert gas configuration. So therefore, cation with pseudo inert gas configuration will have more polarizing power than cation with inert gas configuration. Example, Na plus versus Cu plus. Na plus is having 8 electrons in its valency. Cu plus is having 18 electrons in its valency. This is the cation with inert gas configuration. This is the cation with the pseudo inert gas configuration. So therefore, Cu plus is greater than Na plus, polarizing power law. Whereas Ca plus 2 versus Zn plus 2. Zn plus 2 is greater than Ca plus 2. Because Zn plus 2 is the cation with the pseudo inert gas configuration. Here calcium Ca plus 2 is the cation with the inert gas configuration. Yes, these are the 5 points. And few examples I am taking. Just 3-4 examples. 4 marks question. For first example, lithium iodide, lithium bromide, lithium chloride, lithium fluoride. లిథియం కామన్ గానే ఉంది కాబట్టి యానయాన్ సైజ్ చూడండి, I-, Br-, Cl-, F-. వేర్ దెర్ ఈస్ ఎ లార్జ్ సైజ్ యానయాన్, దేర్ విల్ బి ద మోర్ కోవలెంట్ నేచర్. సో కోవలెంట్ నేచర్ ఈస్ లిథియం iodide greater than, lithium bromide greater than, lithium chloride greater than, lithium fluoride. This is what covalent nature. Whereas lithium chloride, beryllium chloride, boron chloride. So here oxidation state of the boron is +3, oxidation state of beryllium is +2, oxidation state of lithium is +1. And all these cations are isoelectronic species, means they are having same number of electrons. So therefore, but as the number of positive charges increases, polarizing power of the cation increases. So covalent nature, BCl3 greater than, BeCl2 greater than, LiCl. This is what covalent nature. Sometimes FeCl2 versus FeCl3. Obviously, FeCl3 is having more covalent character than FeCl3. And NaCl versus CuCl. Cu plus and Na plus. Cu plus is the cation with inert gas configuration. Na plus is the cation with, sorry, I'm very sorry. Cu plus is the cation with pseudo inert gas configuration. Na plus is the cation with inert gas configuration. So pseudo inert gas configuration contained cation will show the more polarizing power. So therefore CuCl is greater than NaCl. That is also what covalent nature. And finally, calcium chloride versus ZnCl2. Same story. ZnCl2 is greater than CaCl2, covalent nature. So therefore, Fajans rules, what is the meaning of the Fajans rule used to determine the covalent character in ionic bond? So size of the cation, size of the anion, number of positive charges, number of negative charges, cation with the pseudo-inert gas configuration. Enough, right? Yeah. Second question from chemical bonding, the question which regularly encountered. That will be hybridization of the PCl5 molecule. Hybridization of the PCl5 molecule. PCl5 molecule. First of all, what is the meaning of the hybridization? The intermixing of the valency atomic orbitals, which are having difference in size, difference in shape, and almost equivalent amount of energy. ఎనర్జీలో కొంచెం మరీ ఎక్కువ డిఫరెన్స్ ఉండకూడదు, కొంచెం ఎనర్జీ డిఫరెన్స్ ఉన్న వ్యాలెన్సీ అటామిక్ ఆర్బిటాల్స్ అన్నిటిని మిక్స్ చేసి వీ హ్యావ్ టు ప్రొడ్యూస్ ఏ డిఫరెంట్ సెట్ ఆఫ్ ఆర్బిటాల్స్. Those different set of orbitals are called hybrid orbitals and the phenomena is called hybridization. Now I have to prepare PCl5 molecules. All the phosphorus chlorine bonds should have equal length. Equal length. Okay, then basically the atomic number of the phosphorus is the 15. Electronic configuration, it will be 1s2, 2s2, 2p6, 3s2, 3px1, py1, pz1, and here 3dz square 0. So many d orbitals we are having, but intuitively I am taking only 3d. Now how many unpaired electrons are there? Only 3 unpaired electrons are there. Actually, this is the ground state electronic configuration of the phosphorus. Ground state electronic configuration of the phosphorus. But here one phosphorus has been bound up to 5 chlorine molecules or 5 chlorine atoms. Means phosphorus should acquire 5 unpaired electrons in its valency shell. ఇప్పుడు ఇక్కడ 3s2 లో ఉన్న ఎలక్ట్రాన్ ని అన్పేర్ చేసేద్దాం, డీపేర్ చేసేద్దాం. You have to go to excited state electronic configuration. 1s2, 2s2, 2p6, 3s1, 3px1, py1, pz1, and 3dz square 1. Now these valency atomic orbitals which are having one unpaired electron each, one s orbital, 3 p orbitals, one d orbital. Totally how many atomic orbitals are participating into the hybridization? 5 atomic orbitals. Hence you will get 5 sp3d hybrid orbitals. 5 sp3d hybrid orbitals. Those 5 sp3d hybrid orbitals will be placed around the phosphorus like this. Then so these 5 are the sp3d orbitals. sp3d orbitals. Oh, sorry, I can't write here. Okay, sp3d orbitals గుర్తుంచుకోండి. Each sp3 orbital contains one unpaired electron. One unpaired electron each. Now, what is the electronic configuration of the chlorine? Chlorine atomic number is 17. Electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3px2, py2, pz1 number. One unpaired electron is there in pz orbital. pz orbital లో ఒక unpaired electron ఉందమ్మా. One unpaired electron is there in pz orbital. 1 minute. pz orbital. Okay. Now each sp3d orbital of the phosphorus will overlap with the 3p orbital of the chlorine. So this is the electron carried by the chlorine. So total 5 sp3d p overlappings. sp3d p overlappings. Hence 5 sigma bonds. 5 sigma bonds. So therefore, if intuitively the structure will be phosphorus, chlorine, chlorine, chlorine. And these three chlorines which are equatorial bonds, they will produce the one trigonal planar. And two chlorines which are present in axial directions. Axial directions. So finally it will gives you so the shape of the molecule is trigonal bipyramidal. Trigonal bipyramidal. So hybridization is sp3d. Shape of the molecule is trigonal bipyramidal. If you keep plainly, the shape will be like this. As your wish అమ్మా మీ ఇష్టం మీరు ఎలా రాసుకోవాలనుకుంటే అలా రాసుకోవచ్చు ఎగ్జామ్లో. కాకపోతే కంటెంట్ క్లియర్గా ఇస్తే చాలు. హైబ్రిడైజేషన్ ఎలా తీసుకొస్తారు, ఎన్ని అన్పేడ్ ఎలక్ట్రాన్స్ తీసుకొస్తారు, ఈ కంటెంట్. దెన్ యాంగిల్స్. ఈక్విటోరియల్ బాండ్స్ లో యాంగిల్ విల్ బి 120 degrees. యాక్సియల్ కి ఈక్విటోరియల్ కి బాండ్ యాంగిల్ 90 degrees. రెండు యాక్సియల్ బాండ్స్ కమ్మ ద బాండ్ యాంగిల్ విల్ బి 180 degrees. అంటే ఈ హారిజాంటల్ గా ఉన్న బాండ్, ట్రైగోనల్ ప్లేనార్ లో ఉన్న బాండ్స్, ఈ క్లోరిన్ క్లోరిన్ ఈ క్లోరిన్, ఆ బాండ్స్ ఏమంటారంటే ఈక్వటోరియల్ బాండ్స్. ఈక్వాటోరియల్ బాండ్స్. ఇక్కడ వర్టికల్ గా ఉన్న బాండ్స్ ఏమంటారంటే యాక్సియల్ బాండ్స్. Axial bonds. So PCl5 molecule contains three kinds of bond angles: 120 degrees, 90 degrees, and 180 degrees. So this is simply about the hybridization of the PCl5 molecule. Okay na? Yeah. Thank you very much, Amma.